Hello guys, it's Joe Kissinger. I'm a third grade teacher at the Syracuse Academy of Science and Citizenship in Syracuse, New York. And today we are going to be learning about line plots. So starting with first things first, what is a line plot? So our page here tells us a line plot is a way to organize a set of measurements like the length of young sea lions at the aquarium. So we're going to look at our data here. We have all of these different lengths of the sea lions at the aquarium in inches. So we can then use a number line to make a line plot. A number line is like a ruler or a tape measure. The numbers have equal spaces between them. So the space between any two numbers is going to be the same. The numbers are in order and no numbers are skipped. So if we look at our line plot down, or not our line plot, but our number line, I should say, down here, and our ruler goes 48 inches, 49 inches, 50 inches, 51, 52. Our number line in the bottom here goes the same way. It says 48, 49, 50, 51, 52, and those represent inches, just like on a ruler. So it asks us to circle the lengths of the shortest and the longest sea lions on the ruler and the number line. So can you find the two numbers? The one that represents the shortest sea lion and the one that represents the longest sea lion on our ruler and on our number line. So go ahead and take a second and see if you can find those two. So the length of our shortest sea lion, if we look up top here, is 48 inches. So let's find down our ruler and our number line. Right here and right here. And then if we want to find the number that represents the longest sea lion, that would be 52 inches. There's no numbers on our data here that are higher than or greater than 52 inches. So 52 is right here at the top. So our lowest number that we need is all the way to the left, and our highest number that we are going to need will be all the way to the right. So a line plot can help you show measurements. This line plot shows the lengths of sea lions. The number line starts at 48 because the shortest length is 48 inches. Why does the number line end at 52? So the number line ends at 52 because the longest sea lion is 52 inches. So our shortest sea lion is 48, so our number line will start at 48, and our longest sea lion is 52 inches, so we will end at 52 inches. So let's take a look at our line plot here. So the title tells us what the graph is about. Right here, sea lions measurements. The numbers along the bottom show all of the lengths. So these are all the lengths that are represented. Then we have an X for each sea lion length. So each sea lion that measures one of these lengths gets an X. And the label tells us what the numbers mean. So these numbers are the sea lion's length in inches. The line plot shows that two sea lions, for example, are 49 inches long. So we can look at the number 49. We see that there's two X's. That means there are two sea lions that are 49 inches. So the question down here asks us, how is the number line on a line plot like a ruler? And how is it different? So we talked about that at the very beginning of our page. How is a line plot similar to a ruler? So actually think about that for a second and see if you can come up with your own answer. Write it down if you need to. At any point, if you need to pause the video, feel free to give it a pause and think about it a little bit and then resume when you're ready. So how is the number line on a line plot like a ruler? And how is it different? So we talked about the ways that a line plot and a ruler are similar. And to refresh, we'll scroll up here and take a look. So a number line is like a ruler or tape measure because the numbers have equal spaces between them, just like on a ruler. The numbers are in order. They go up by one each number, and then no numbers are skipped. So something that you should notice when you're looking at this line plot here is, see this number 51 here? Well, there aren't any C lines that are 51 inches. So we don't have any X's there. But when we're making our number line on the bottom, we wouldn't go 48, 49, 50, and then skip right to 52. We still need to put 51 in there to show that there are no C lines at 51 inches. So even if we don't have any data for that number, for that length, in this case, we still need to include it on our number line. So that's important to remember. Now, we talked about how a number line and a ruler are similar, but how are they different? So think about how these two things are different. So on a ruler, every mark, so every number on this ruler, this is in inches. So every number represents 1 inch. So in between the numbers on the ruler, we know that space will be 1 inch. When we're on a number line doesn't necessarily have to be spaced out in 1 inch spaces or 1 inch increments or 1 centimeter. It can be any distance between those numbers. It just tells us what those numbers are. So these could be, if it didn't tell us these are inches, this could be 48 feet, 49 feet, 50 feet. And we wouldn't have to put those numbers on the number line a foot apart and use a piece of paper this big. We could use the same size number line, and we could just tell the reader that that those are feet and not inches. So that's the main difference between a ruler and a number line. A number line can just represent the distance, whereas a ruler or a tape measure has to show the exact distance between those numbers because it's used to measure. So those are a little bit different. And speaking of measuring, this next part here would require that we have a ruler on hand to complete. And I know that not everybody has a ruler at home. So what I'm going to do is I'm going to skip by this part, and we're just going to do the next part of the lesson. They'll show us how to do the same exact thing, except without requiring us to have a ruler. So let's look right here. And if you could, and if you don't already, make sure that you have a piece of paper and a pencil. So grab one of these. And one of these, and we will start on this first problem right here. So it says Rachel wants to make a plot to show the lengths of 6 rooms. Write the numbers Rachel needs to put in the line plot. So we have our data right over here. Rooms A, B, C, D, E, and F, and then their length in meters. So what I want you to do is draw this number line here on your paper, and I'll show you exactly how that should look. So do your best to draw that right on your paper here, and we're going to do 6 little marks on here. 1, 2, 3, 4, 5, 6, and try to make them evenly spaced apart as well as you can. So it should look just like that. And then what we're going to do where those boxes are is show us what numbers we would need to put on our number line in order to plot this data on a line plot. So go ahead and give that a try. and you can pause if you need a little bit more time, and then resume the video when you're ready. I'm going to write my numbers in here in the meantime. All right. So a good way to start out with a number line is, let's look if we look at our lengths, what is our lowest number here? Find the lowest number. It's 6, right? So the number 6 is going to go right here on your number line, right in that first box. And then let's look at our highest number. Our highest number is 11. So 11 will go all the way to the right on our number line. And then they're just going to go up by 1 on the next rest of the number line. So if you look right here, I'll make it a little bit bigger so everyone can see. We have 6, 7, 8, 9, 10, and 11. Now, I know we don't have any rooms that are 7 meters long. And it looks like we have all of the other numbers on here. But remember, we still need to put the number 7 on there because we can't just skip it. We need to make sure that those numbers go in order. So it should be 6, 7, 8, 9, 10, and 11. The next one says explain. Look at the line plot at the right. Nate says more people jumped 4 feet than any other length. Explain why Nate is wrong. So let's look at our line chart here. So we have 4 X's, 3 X's, and 2 X's. Now, what did Nate do wrong here? Why does he think that more people jumped 4 feet than any other length than 3 feet? We can see that there's 4 X's here and that there's 3 X's here. So those X's are just really big on number 4. So Nate just looked at the size of the X's on his chart. He made those ones a little bit bigger. The only thing that matters, the size of those X's don't matter. The only thing that matters is that the number of those X's, the number of plots that we have for our data. So more people jumped 3 feet than any other length, not 4 feet. And then let's look at one more here. It says Bo made a line plot to show how far he ran each day. Tia says the farthest Bo ran in one day is 3 miles. Is she correct? Why or why not? So let's look at 3 miles. So we got to look at our length in miles. And that's 3 right here. And Tia says that the farthest Bo ran in one day is 3 miles. Well, he ran 3 miles how many days? 1, 2, 3. 3 days. But were there any days that Bo ran more than 3 miles by looking at our line plot? So think about that. Are there any days on our chart here that shows that Bo ran more than 3 miles? Right. He ran 4 miles, 5 miles, and 8 miles. It didn't ask if he ran 3 miles more times than any other day. What it asked is, was the farthest that he ran in one day 3 miles? So we have to remember what these X's mean. They mean how many times something happened, or how many pieces of data we have for that number, not how far they ran, or the length, or whatever our measurement is on our number line on the bottom. So we're gonna end right there. Hopefully that clears up line plots a little bit, and we're understanding how to make a line plot and how to read a line plot a little bit better. And we're going to continue kind of on a similar topic in our next lesson as well. So everyone have an awesome rest of your day, and we'll see you next time.